Information related to a titration experiment is given in the balanced equation and table below. Based on the equation and the titration results, what is the concentration of H2SO4? Okay, so we know that our titration equation, on table T, our titration equation right here, titration is the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. In other words, acid times acid equals base times base. Okay, so you just got to make sure that you put your acid values for molarity and volume on one side and the base values on the other side. Now this question does have a twist. Let's go ahead and work it out, and then see what that twist is, all right? The other thing I'd like to point out here is that we do have the sulfuric acid right here and the potassium hydroxide right here, and so we know that this is the acid and this is the base, although you don't really need that to answer this, but it makes sense to look at it. Okay, so the volume of the acid was 12.0 milliliters. The concentration of the acid is my unknown. The volume of the base is 36.0 milliliters. And the concentration of the base is 0.16 molar. Now, I got to multiply and then get x alone. So I'm going to multiply 36 times 0.16, and I get 5.76, and that is equal to x times 12 milliliters, right? Okay, so I'm going to divide both sides by 12, and I get x equals 0.48, and this is concentration, molar. Okay, now that was calculated correctly, 0.48 molar, but there's a problem here. Look at your choices. 0.4 molar, 48 molar isn't even given as a choice, and you're lucky it isn't, because the fact that it's not there means that you got to go back and look to see what the problem is, right? Here is the issue. Sulfuric acid is what is known as a DiProtic acid. Remember that acids are just a bunch of free protons, right? DiProtic means that the acid has two hydrogens in its formula. Look at that, H2SO4. And that means that the number of hydrogens you get is double what you would get in the same concentration, the same molarity of a monoprotic acid like hydrogen chloride, right? So if it was hydrochloric acid, HCl, we wouldn't care about this because it would just be one hydrogen. But because it's two hydrogens, that means that it has double the neutralization power of this base, of this potassium hydroxide, right? That means that it's 2 times the power. Now, what does that mean? That means if we calculated out 0.48 molar, we really only need half of that because it's double the concentration of the hydrogen ions. Number 3, 0.24 molar is the correct concentration for the diprotic acid, sulfuric acid.